With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is, a wheel of radius r rolls without slipping with a speed of v on a horizontal road. When it is at a point A on the road, a small blob of mud separates from the wheel at its highest point and lands at a point B on the road. So in that case, we have to find the distance between these 2 points A and B. So let's see the solution. So first of all, let's understand the scenario which is explained in this question. So let's suppose we have a wheel, okay, rotating on horizontal surface, let's suppose on this, without slipping. Okay, now this wheel having the radius of a small r as per the question. Okay, this is nothing but the center of the wheel. Okay, now according to question, the velocity for the wheel is given to us, that is in horizontal direction, is nothing but v. Okay, now let's suppose where the wheel is attached to the road is nothing but a point A. Okay, now when it is at a point A on the road, a small blob of mud separates from the wheel at its highest point, means at this point, and lands on point B on the road. Means obviously it will do a projectile motion like this, okay, and it will land onto the road, let's suppose at point B. So as per the question, we have to find this distance AB. Okay, so let's suppose this distance is nothing but x. Okay, while as per the question it is given the radius is r and the velocity in horizontal direction is nothing but v. Okay, so first of all, what we will do here, while let's suppose it's rotating in this direction with angular velocity of omega, so obviously just because of this, the velocity will be in this direction, that is omega into r. While if we talk about this point, so at this point the velocity will be in this direction, that is v, and the another velocity, just because of angular velocity, that is omega, this will be in this direction, that is omega into r. Now at this point, as because of no slipping between this wheel and road, we can write v will be equals to omega into r. Okay, while if we talk about point P, so we can write here at point P, okay, at point P, the velocity will be, let's say, Vp, okay, this will be nothing but is equals to, that is Vp equals to v plus omega into r. Okay, now if we see here, if we completely observe the scenario, so it is nothing but forming and projectile motion condition, right? So here we can say that is we have an particular height from which, let's say, a particle is projected. Okay, this is nothing but point A, this is point B, this is point P. From this point a particle is projected to this point B. Okay, while this much of length according to question is twice of r, and its initial velocity is nothing but, okay, this we have to find, that is v equals to omega into r. So if we substitute here in the place of omega r as v, so what we get, that is Vp will be equals to twice of v. So here we can say that this particle is projected nothing but with the velocity of 2v. Okay, so in this case we have to find this displacement x. Okay, so what we will do, we simply do one thing, that is we will use the equation of motion in both direction, that is in upward direction, that is in y direction, and in x direction. Okay, so first of all, using for the upward direction, so in upward direction we know that the velocity component vy will be equals to 0, okay, and the acceleration component, that is ay, will be nothing but equals to minus of g, while the value of s will be equals to minus of twice of r. So if we substitute these values in the equation of motion, that is s, this is equals to ut plus 1/2 of at square. Okay, so this will become equals to, that is initial velocity is 0, so this term will be going to 0, while if we substitute here the value of s and a, so this will become minus of twice of r, this will be equals to 1/2 of value of a, that is minus g into t square. Now this minus minus get cancelled. So from here what we get, that is the time of flight. Time of flight t is equals to 2 under root of r divided by g. Okay, under root of r divided by g. Now this is what we got the time of flight for this particle to reaching up to this b point. So simply by using the equation of motion in x direction, we can write the s of x, this will be equals to ux into t plus 1/2 of x t square. Now as we know that in horizontal direction the acceleration is nothing but equals to 0. So this term will going to be 0. So what we get, that is s of x, this will be equals to ux t. Now here s of x is nothing but x. So what we get, that is x will be equals to u of x is nothing but the velocity by which it is projected, and here according to our calculation we got here twice of v, so this will become 2v into time of flight, that is 2 under root of r divided by g. So this will become x is equals to 4v under root of r divided by g. Okay, meter. So this will be the required distance between this a and b. So according to given options, option C will become correct answer for this question. So this is the required solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.